Hi everyone, this video is going to help us think through the distributive property a little bit, about how the distributive property is related to finding the area of a rectangle, just like focus number 12. And it will additionally help you with part B on homework number 6, where you're asked to find possible dimensions of a rectangle. So you may notice that I have different numbers here. In this problem, we have a large rectangle that has an area of 36 square units, but in your homework you have a rectangle that has an area of 28 square units. I just want to talk to you about how you would go about solving this problem so that you can do part B on your own. So let's read through what the problem's asking us. It says a large rectangle, so this one down here, has an area of 36 square units. It has been divided into two smaller rectangles. One of the smaller rectangles has an area of 6 square units. That's written right here. What are the possible whole number dimensions of the large rectangle? All right. So in this problem, there are a couple things we have to think about first before we start listing out the possibilities. So first, if this whole large rectangle has an area of 36 square units and this already has an area of 6 square units, what's the only possible area of this other smaller rectangle? Well, 36 minus 6 is 30. So I know for a fact that this rectangle right here has to be 30 units, square units, whoopsies, 30 square units. So now I have to figure out, okay, I want to know the whole number dimensions of this larger rectangle. So let's go through and start listing some of the possibilities. And I'm just going to keep this one up here like this and try my very best to draw some other rectangles. So let's say we had this one. Let's imagine that these lines were actually parallel and straight. So again, we know that this smaller one is 6 square units and this one is 30 square units. So let's start thinking about some possibilities. I'll do this one in purple. So if this is 6 here, well, what are the possible dimensions of a width and a length that would get us 6 when multiplied together? Well, couldn't we just multiply 1 by 6? Remember, area equals width times length. If this is length and this is width, you can interchange these. This could be length, this could be width because of our good friend, the commutative property, but I'll just name them width and length for now. So if this is 1 and this is 6, this definitely makes 6. But now we have to figure out, well, if this is 1 over here, we know that this side over here is the same length as this side over here, same length as this side over here, especially if we were able to draw straight parallel lines. It would actually look like it. But in our world, they are exactly the same. So what's the only number, if this is 1 here, that I can multiply by 1 to get 30? Well, that has to be 30. 30 is the only number that I can multiply 1 by to get 30. So what are the dimensions of this large rectangle then? I have 1 times 6 plus 30, which is equal to 1 times 36. So that's one possible dimension of, or set of dimensions for this rectangle here. There are other possibilities. Let's think about it. Well, if again this is 6 and this is 30, I could use the exact same factors and just put them in different places. So I can say, well, I know 1 times 6 equals 30, but I also know that 6 times 1 equals 30. So again, this width is the same as this width over here, so I know that the width of this other smaller rectangle over here has to also be 6. So I'm thinking, what number times 6 equals 30? That number is 5. So now we have dimensions of another large rectangle. This is a 6 by 1 plus 5 rectangle, also known as a 6 by 6 rectangle. Are there possibly other possibilities? I think there might be. Let's try a couple more. In your head, before I say it out loud, think to yourself, how is she getting these dimensions here? How is she getting like 1 and 6 and 6 and 1? What numbers am I thinking of to get these dimensions right here? Think to yourself, what could that be? If you're thinking factors of 6, you're totally right on. I am thinking of factors of 6 to find these dimensions here. So what are some other factors of 6? I think now I'm going to try 2 times 3 up here. So 2 times 3 definitely equals 6. And I know this is also equal to 2, so I'm thinking to myself, what number, this dimension up here, times 2 equals 30. I know that number is 15. So I now have another set of possible dimensions for this large rectangle. I have a 2 by 3 plus 15. And that is also known as a 2 by 18. And I think there's one more possibility. I hope you have thought of it in your head already. Let's draw it out. If you're using graph paper to draw this, please try to be a little bit neater than I am. I'm not setting a good example. I'm just learning how to draw on this tablet program. Let's think. Well, just like I could reverse this 1 by 6 here into a 6 by 1, we can reverse this 2 by 3 into, you guessed it, a 3 by 2. All right, so 3 times 2 definitely equals 6. This width is the same as this one over here because it's a rectangle, and that's a property of a rectangle. So what number, this dimension up here, times 3 equals 30? That's just 10. So here's our last possibility. We have a 3 by 2 plus 10, which is also known as a 3 by 12 rectangle. We can also check to make sure these all equal 36 square units, just like it was supposed to. So we have a 1 by 36, 1 times 36 equals 36. We have a 6 by 6, 6 times 6 equals 36. We have a 2 by 18, 2 times 18 equals 36. And we have a 3 by 12, 3 times 12 equals 36. Now, how do I know there aren't any more? Well, I know that I first need to find whole number dimensions that make up the smallest rectangle of 6. And I can't try any other numbers. I already tried 1, I used 2, I used 3. 4 is not a factor of 6. There's no whole number that I can multiply 4 by to get 6. And same with 5. There's no whole number that I can multiply 5 by to get 6. So I know I'm finished with this problem, and you're going to do something really similar with problem B on homework 6. I hope this video helped a little bit and showed you a little bit more of what is happening in that great distributive property. Thanks for watching.